Welcome to the office. We want to continue taking a look at cosets. Again, here we look at a sequence of 3 examples where we find left cosets, right cosets, compare them, and then go ahead and rearrange that multiplication table for our group to try and observe whether those cosets create a coset group themselves. All right, let's see here. For this example, we are considering D4, okay, the isometries um, of the square. So we have rotations, right, 4 rotations, no rotation, 90, 180, 270-degree rotations, and then various reflections over, let's see here, I want to say mirror reflections over um, that pass through the sides, and then mirror reflections that pass through the diagonals. I think that might be the case. Anyway, you can review that content if you wish as well. But here we want to simply find the left cosets of this subgroup, which we can call H, and the multiplication table is given below. All right, so if I want to find the left cosets, what I'm interested in doing is multiplying my subgroup H on the left by each of the elements. So since I'm multiplying on the left, I'm looking at multiplying by each of these. And my subgroup itself contains rho naught and mu1. I'm sorry, mu2. And mu2. Excellent. So I want to take rho naught times h. That will give us rho naught times rho naught and rho naught times mu2. Right, that's just our definition of multiplying on the left by rho naught. That's our left coset. This is exactly rho naught mu2. And that's the same as multiplying on the left by mu2, rho naught mu2. Excellent. Next is rho 1. So what does it look like to multiply by rho 1 on the left? Again, that's rho 1 times rho naught, and then rho 1 times mu2. Remember that rho and mu and delta here, while having specific interpretations within the context of isometries of a square, they're actually, let's see here, those are actually permutations. So we're looking at a subgroup of the permutation group S4, okay? So this is a subgroup of S4, really. And we're looking at subgroups of that, or right, one specific subgroup of that. Anyway, multiplying by rho 1 on the left gives us rho 1 delta 2, rho 1 delta 2. And that's the same as multiplying on the left by delta 2. Multiply by delta 2 gives us delta 2 rho 1. Excellent. As we continue on here, I'm just going to write the result. I'll line up these results for convenience. Rho 2 gives us rho 2 and mu1. Rho 2 and mu1. That's the same as multiplying by mu1. Again, if you're uncertain, it's the same thing because when I multiply on the left by rho naught, well, let's do it for this example. When I multiply on the left by rho 2, multiplying on left by rho 2 gives me rho 2 and mu1. Multiplying on left by rho 1 gives me, sorry, mu1 gives me mu1 rho 2. Rho 2, u1. Okay, it's the same set. And then finally, rho 3. When I'm multiplying the left by rho 3, I get rho 3 and delta 1. That's the same as multiplying on left by delta 1, which gives me delta 1 and rho 3. Excellent. So this right here gives us our left cosets. The left cosets in this case are exactly rho 1 mu naught, rho 1 delta 2, rho 2 mu 1, and rho 3 delta 1. Excellent. That's all that we wanted to do for this video. So let's go ahead and find the right cosets in our next video.